everyone, welcome back to CloudOps Craft. Today we are going to discuss about what is Kubernetes, why the world runs on it, and Kubernetes architecture. Let's start. Imagine this: you work at a company that just built a cool web app. You package it into a Docker container and deploy it on a server. Everything works fine at first until your app becomes popular. Traffic surges, customers join from around the world, and suddenly one server is not enough anymore. You spin up a few more containers manually, but then one crashes, another gets stuck, one node runs out of memory, and your Friday evening turns into a call. That's where Kubernetes comes in, your container orchestrator. Think of Kubernetes as the operating system for the cloud. It does not just run containers, it manages them automatically. It decides where each container should run. It keeps them alive even if something crashes. It scales up when traffic increases. It heals itself when something breaks. Okay. In simple words, Docker gives you the container. Kubernetes tell the container where, when, and how to run at scale. Okay. Why the world runs on Kubernetes? The major thing is scalability. App grow automatically when demand spikes. Second is portability. It works anywhere on AWS, Azure, Google Cloud, or even your laptop. It's like a universal adapter for running containers anywhere you want. Third advantage is self-healing. Okay, third reason is self-healing. If a container crashes, Kubernetes restarts it. No human intervention, no downtime. Rolling updates and rollbacks. Fourth reason, you can deploy new versions of your app gradually and safely. If something fails, roll back instantly. Fifth reason is declarative management. You describe your desired state in YAML, and Kubernetes keeps the cluster in that state continuously. Like saying, I want 5 copies of this app running. Okay, Kubernetes ensures it stays that way. Okay, next is community and ecosystem. Every major company uses it. It's open source, cloud neutral, and continuously evolving. Okay, Google originally created Kubernetes from their internal system called Brog. Okay, now most of the companies runs their application using Kubernetes cluster because it offers speed, automation, and resilience. Okay, let's imagine Kubernetes as a brain and body system. The control plane, okay, which is the control plane, okay, is the brain, and the worker nodes are the body parts that do actual work, running your applications inside container. Okay, when you give Kubernetes an instruction like, hey Kubernetes, run 3 copies of my web app, okay, the brain, which is control plane, takes your command, plans how and where this container should run, and sends instructions to the body, which is worker nodes, to execute. Let's break down this clearly. Okay, the big picture. This is the cluster overview. Kubernetes has 2 main sections. One is control plane, another one is worker nodes. Okay, control node and master node and worker node. This control plane is there, right? This is master node, makes all decisions. This is worker nodes. Okay, run your actual app, which is pods. You can think it like a restaurant. Okay, the manager, which is control plane, takes orders, plans, and assign tasks. The chefs, which is worker nodes, actually cook the food, okay, which is running container. Without the manager, chefs couldn't know what to do. Without chefs, the manager has no one to cook. Together they make it work. Okay, the control plane, the brain. Okay, let's open up the master node and see what's inside. Okay, first one is API server. Okay, this is the front desk and receptionist of Kubernetes. Every command we run, like a kubectl get pods, kubectl play -f deployment.yaml, first it goes to the API server. It's a central communication hub. Okay, we can say this as a central communication hub. It has a central communication hub. Okay, everything passes through it. Think of Kubernetes gatekeeper. Think of it as a Kubernetes gatekeeper. Nothing enters or leaves without the API server approvals. Okay, next is etcd. You can see This is a database of Kubernetes. Okay, it stores the desired state, all information about pods, nodes, services, etc. For example, if I said I want 5 replicas, etcd stores that as a desired configuration. If something goes wrong, Kubernetes checks etcd to restore that state. Okay, next is scheduler. Okay, which is the one it will decide, okay, where pod should run. It decides where pods should run. Okay, it looks at every worker node's CPU, memory and load and picks the best one for the job. Okay, scheduler is like an HR manager assigning employees, which is pods to departments, nodes based on skill and availability. Next is controller manager. This is an automation engine. Okay, this is an automation engine of Kubernetes. It continuously watches what's running versus what should be running. If your pod crashes or disappears, the controller tells the system to recreate it. It's like an autocorrect system for your cluster. It always bringing things back to the desired state. Okay, or like a cloud controller manager also will be there. If you are running Kubernetes on cloud provider like AWS, Azure or GCP, this component helps integrate Kubernetes with the cloud. For example, creating load balancers or attaching storage. Think of it as a translator between Kubernetes and your cloud provider. Okay, the next is worker nodes, which is the body. Now let's see what happens on these nodes that actually runs your app. First is kubelet. You can see, right? This is an agent running on each worker node. It listens to the control plane and makes sure the containers are running as instructed. If the container plane says run this pod, Kubernetes ensures it happens. Okay, it's like a supervisor running, ensuring all workers on that node are doing their jobs. Okay, next is kubeproxy. Okay, it will also run on all the nodes. It handles networking. Okay, how pod communicate within the cluster and with the outside the world. Okay, it manages IP rules, routing and load balancing between pods. Okay, think of kubeproxy as a traffic officer that directs requests to the right pod. Okay, so next is pod. You can see it's a smallest deployable unit. Okay, in Kubernetes. Okay, yeah, pod can have one or more containers that always run together. They share storage, network and configuration. Yeah, example, a pod running a web server and a sidecar container for logging. A pod is like a shipping container, okay, holding one or more tightly connected goods. Okay, how it all works together. Okay, let's discuss that. Okay, when kubectl also we have to discuss, right? Any idea about kubectl? Here you can see this is a CLI tool. Okay, this is a CLI tool. For what purpose we need a Kubernetes CLI? Any idea? What if you know, let me know on the comment section. I'll pause the video and let me know on the comment sections. Okay, let me explain. The thing is, kubectl is a command line tool used to interact with Kubernetes cluster. Think of it like a remote control CLI for Kubernetes. Whatever you want Kubernetes to do, you tell it using kubectl only. Okay, so it creates objects like it. You can view objects, you can modify objects, you can delete objects, you can deploy, you can apply your YAML configuration files, you can do port forwards and services and all. Why kubectl is needed? Because Kubernetes is just an API server, right? Kubectl does not directly manage pods or nodes. It only talks to the API server. Okay, it only talks to the API server. Okay, so the flow will be you to kubectl. Okay, kubectl to K8s API server to scheduler. Okay, this is how the flow will be. Okay, so consider you are writing a configuration. Okay, you want to do something in Kubernetes. Okay, for example, we know with the help of kubectl only we can communicate with API server, right? So I am typing like a kubectl apply -f app.yml. Okay, consider I wrote some code to create a pod. Okay, so what happens in the backend? Okay, I'm just writing app.yml just to create one pod. Okay, so what happens is this kubectl client is there, right? This kubectl talks to API server. Okay, this API server stores your desired state in the etcd. The scheduler decides which node to place the pod on, and kubelet is there, right? Kubelet, this is on the node that receives the instructions and create the pod. Okay, so the controller manager ensures everything matches the desired state. Next is kube proxy. Okay, it manages networking so your app is reachable. Okay, and all this happens automatically in seconds. Okay, for example, okay, when you deploy your web app, okay, consider front end runs on node 1. Okay, let's have an example. Okay, so front end runs on node 1, and back end runs on node 2, and database runs on node 3. Okay, for example, if you are using AWS K8s, then all these nodes are easy to instance. Okay, if node 2 suddenly goes down, okay, consider node 2 suddenly goes down. Okay, Kubernetes detects it instantly and reschedules the pods to another healthy node. Okay, these all nodes are virtual machines only. Okay, all are virtual machines only. Okay, so it will schedule the pods to another healthy node. No downtime, no manual work. That's the power of Kubernetes architecture. Okay, it has self-healing, scalable, and intelligent. Okay. I have a question for you. What happens when a node goes down in Kubernetes? Any idea? Let me explain. When node 2 fail, Kubernetes needs to detect that and then move the pods, okay, that were running on it, okay, to somewhere else. For example, node 2, in our case node 2 was failed means, okay, it will detect it and it will move those pods to node 1 and node 3. This entire process involves multiple components, not just a scheduler. Okay, let me explain that step by step. Kubelet, okay, on each node it will be having, right, we discussed, right, it's like an agent, it will run on each node, right? So every node runs a process called the kubelet. Okay, so the kubelet constantly sends odd bit to the API server. Okay, it will constantly sends odd bit, just kubelet to API server, odd bit, it will send odd bit. Okay, for typically every 10 seconds. Okay, if kubelet stops sending odd bits, for example node 2 is crashed or lost network connection, the control plane notices it. Second, what will happen? Node controller will be there inside the controller manager. There are so many controllers out there inside the control manager. Okay, the node controller, what it will do, it is a part of kube controller manager. It is responsible for monitoring node health. It checks if the API server has not received odd bits from a node. By default, it will check for 40 seconds. For example, if kubelet is not sending odd bit to API server for 40 seconds. Okay, so every 10 seconds it will typically send. It will wait for 40 seconds. Okay, even after 40 seconds, it is not receiving odd bits, means it marks that node as false. Okay, from ready to, it will move to not ready after 40 seconds. Okay, after 5 minutes, after another 5 minutes, by default it evicts pods and move like pods from the node. Okay, we know after 40 seconds it will become not ready. Okay, every 10 seconds it will send the odd bit. Okay, if it is not receiving any odd bit for 40 seconds, then it will become not ready. Once it became not ready, okay, after 5 minutes, okay, it will evict all the pods from node 2. Okay, and it will move those pods to node 1 or node 3. Okay, scheduler, what it will do, once the pods are marked as unscheduled because their node went down and they are evicted, right, the kube scheduler steps in and finds a new healthy node, whether it may be node 1 or node 2, okay, to place those pods on. Okay, it will decide based on CPU, memory and resources limitations. Okay, think of it imagine Kubernetes, okay, like as an airline system. Okay, node controller is a flight operations team. It detects that one plane node 2 went out of service, means it cancels the flight which is pods on that plane. Okay, so this is how it works. Okay, now I hope you understood the flow from user to API server, API server to etcd. Let me explain that flow one more time. So component overview visualization should be user is a kubectl. They will use kubectl to access. Okay, user can communicate with API server first with the help of kubectl. Okay, which is entry point. Okay, API server to etcd to store cluster state, etcd to scheduler. Okay, it assigns pod, it decides where to place the pod. Controller manager, okay, maintains decide state. Kubelet, okay, runs pod. Kube proxy, okay, networking and pod, which contains our containers. Okay, this is the flow. Okay, I hope you understood. If you like this breakdown, subscribe to CloudOps Craft. We will simplify cloud and DevOps concepts every week. Thank you.